There is a train station in China so vast that 5 Grand Central terminals could fit inside it with room left over. 16,000 passengers move through it every single hour at peak times. Its roof alone weighs more than 16,000 tons, and it did not start out up in the air. It started on the ground and was lifted 57 meters into place using hydraulic jacks, like raising a steel sky 1 careful meter at a time. This is Chongqing East Station. You will understand why engineers from around the world don't just visit it, they study it, trying to understand not how it works, but how anyone was bold enough to attempt it in the first place. The mountain that had to move. To understand why Chongqing East Station looks the way it does, you first have to understand the city that demanded it. Chongqing is not a normal city. It is a municipality of over 30 million people built across terrain so violently mountainous that traditional urban grids, the neat right angles you'd expect from any major metropolis, simply could not be applied here. Streets climb, dive, spiral, and disappear into tunnels that pop back out 3 blocks away on a completely different elevation. Locals joke that Chongqing has no second floor because every building's second floor is also, somehow, someone else's ground floor, depending entirely on which side of the hill you walked in from. So when planners needed to insert one of the largest, busiest pieces of transportation infrastructure ever conceived into this terrain, there was no empty lot waiting for them. There was only a mountain, and the mountain, quite simply, was in the way. Here is where the story turns from ambitious to almost unbelievable. Engineers did not build around the mountain. They took it apart, piece by piece, and rebuilt the ground itself. The process began with a complete 3D mapping of the terrain. Every contour, every ridge, every fault line digitized before a single tool touched the rock. Then came controlled blasting. Precisely calculated explosions designed to remove specific sections of stone without destabilizing the sections meant to stay. What followed was a staggering operation of earth moving and terracing, reshaping an entire mountainside into something flat enough, stable enough, and large enough to support what would become the largest high-speed rail station on the planet. And they did all of it in 38 months. For context, projects a fraction of this scale, in flatter, easier terrain, routinely it. Chongqing East Station spans somewhere between 1.2 and 1.22 million square meters. To put that into a shape your mind can actually hold, that is roughly 5 times the size of Grand Central Terminal in New York City. building most people already consider enormous. Five of them layered into one structure, carved into one mountainside. The station rises across 8 total levels, 3 of which are dedicated specifically to rail operations, supporting 15 platforms and 29 tracks in total. Platforms stretch over 400 meters long enough to comfortably accommodate the full length of China's fastest high-speed trains, with room to spare on either end. At full peak capacity, the station is engineered to move 16,000 passengers through its halls every single hour, a number that would overwhelm almost any other transit hub on the planet. But which Chongqing East Station was specifically designed, from its very first blueprint, to absorb without buckling. Walk through it, and the scale stops being a statistic and starts being something closer to a sensation. Daylight pouring through skylights set high above platforms buried inside what used to be solid mountain rock. Escalators carrying commuters past glass walls overlooking trains gliding silently 2 and 3 stories below. The entire structure behaving less like a building and more like a small vertical I recently started this channel to take you to the world's most extraordinary and hidden places. And bring you even more breathtaking destinations and make even better videos. Thanks. Now let's keep traveling together. The roof that was built on the ground. If there is one single detail that captures the audacity of this entire project, it is the roof. Most roofs are built where they will eventually sit, piece by piece, level by level, rising along with the rest of the structure beneath them. The roof of Chongqing East Station was not built that way because the scale of what engineers were attempting made conventional construction methods almost impossible to execute safely at height. So instead, the entire steel roof structure, weighing in at 16,500 tons, heavier than several fully loaded cargo ships, was assembled first, completely, at ground level. Then, once finished, it was lifted. Not craned in pieces, not bolted together story by story in the open air, but hydraulically raised as a single, complete structure, sliding 57 meters straight upward into its final position above the station. Picture an object heavier than the Eiffel Tower rising slowly through the air, inch by careful inch. Hydraulic systems calculations said it needed to be. That roof now rests on a series of massive tree-shaped steel columns. engineered with the specific name Huangjue columns, named after a towering native banyan tree famous throughout Chongqing for its broad, deeply rooted canopy. The design is not just poetic, it is functional. These branching steel supports distribute the immense weight of the roof across multiple points rather than concentrating it on single columns, dramatically improving the structure's ability to absorb seismic activity and resist the kind of ground movement that would threaten a more rigid design. In a region where earthquakes are a real structural concern, the station's roof essentially grows out of the ground the way a tree does. Flexible at its branches, anchored at its roots. A station built by machines that think. None of this, the blasting, the mapping, the lifting of 16,000 tons of steel, happened through brute force alone. Chongqing East Station was, from its earliest planning stages, one of the most technologically advanced construction projects in modern Chinese infrastructure. Artificial intelligence systems were used throughout the build to model stress points, simulate seismic responses, and predict how thousands of tons of steel and concrete would behave under real-world pressure. Long before a single beam was placed, fifth-generation wireless networks blanketed the construction site, allowing real-time data to flow between sensors embedded in the structure itself. And engineers monitoring the build from command centers, catching microshifts and stress anomalies in moments rather than days. Construction robots handled tasks too repetitive, too precise, or too dangerous for human crews. Welding, surveying, and material placement executed with a consistency human hands alone could never fully replicate at this scale. The result is a building that is, in a very real sense, partially self-aware. Sensors throughout its structure continue monitoring stress, vibration, and settlement long after construction ended. Feeding data into systems designed to flag problems before they become visible to the human eye. Chongqing East Station does not simply sit on its mountain. It watches itself sitting there, constantly, quietly, the way no train station anywhere else in the world quite does. Way to 14 cities. All of this, the blasted mountainside, the 16,000-ton roof, the AI systems monitoring every seismic tremor, exists for a single, practical purpose: connection. Chongqing East Station serves as a critical node in China's rapidly expanding high-speed rail network, a system that has transformed how this country measures distance. No longer in kilometers, but in minutes. From this single station, high-speed lines extend outward to 14 major cities across southwestern China, threading together a region of staggering size and population density into something that increasingly behaves, transportation-wise, like a single interconnected metropolis rather than a collection of distant urban centers. It is worth placing this achievement in a slightly wider context. China is also home to the highest railway on Earth, the Qinghai-Tibet line, climbing to elevations of over 5,000 meters, where trains pass through landscapes so thin on oxygen that carriages are specially pressurized for passenger safety. That railway represents one extreme of Chinese engineering ambition: height, altitude, the conquest of thin air. Chongqing East Station represents the other extreme entirely, not climbing a mountain, but absorbing one, swallowing it whole, reshaping it from the inside, and building a city's entire transportation future directly into what used to be solid, unmovable stone. Quick pause. I recently started this channel to take you to the world's most extraordinary and hidden places. We're still at the very beginning, so every subscriber really matters. If this kind of content helps you understand the world better, consider subscribing. It helps me keep exploring and bring you even more breathtaking destinations. And make even better videos. Thanks. Now, let's keep traveling together. What the mountain became. Stand on the highest platform inside Chongqing East Station and look down through 8 levels of trains, escalators, skylight-filtered sunlight, and moving crowds, and what you are really looking at is the physical record of a decision. The decision not to build around an obstacle, but to fundamentally reshape it. The decision that 38 months and 16,000 tons of steel and a mountain's worth of displaced stone were a reasonable price to pay for connecting 14 cities and moving 16,000 people an hour through a structure that, on paper, should have been impossible to build at all. The mountain that once stood here is gone now, broken down, mapped, blasted, and reformed into something almost unrecognizable from what it used to be. But in a strange, quiet way, it never really left. It simply changed shape, from a barrier that stopped people into branching steel columns named after trees, holding up a roof that floats 57 meters above platforms where 14 cities now begin. Every single hour, 16,000 journeys at a time. The mountain didn't disappear, it just learned how to carry people instead of standing in their way.